on 3, implementation of partitioning. In this video, I want to explain the implementation idea. Next video, I will show you example. Yeah. All right, so let's start. Straightforward implementation. Yeah. So I want to use 2 steps to explain. The first step, implementation, straightforward implementation. Okay, all right. In this step, we use 2 auxiliary arrays. Extra auxiliary arrays. Okay, the reason to do that, we want to understand the partition step a little easier. Okay, implement, yeah, in that way. Yeah. All right, first try. Yeah. When we start to do partition on this array with the last element as the pivot, yeah, that is our original array. And we scan this array, do processing element by element. Yeah. How do we get a split of 2 subarrays? We can use 2 auxiliary extra arrays. Okay, yeah, in this step. So let's try to make ourselves life easier. Okay, yeah. All right. For the first subarray, we want to have all the elements less than or equal to p. Now, so that's easy, right? So look at the first element. Compare its value with that of the pivot element, p. If it is less than or equal to p, we put in the first subarray. If it's greater or equal to p, greater, yeah, because equal we put left subarray, so we put the right subarray, greater, okay, yeah. So in that way, we go through all the elements. Then we can get these 2 subarrays, right? It's that simple. We only need to scan the array once. For each element, we do 1 comparison. We know which subarray to put it. After we finish the scan, we split original array into 2 subarrays. How simple it is, right? Yeah. Although this straightforward way is very simple, but it has a big problem. So what's that big problem? Okay, yeah. So the big problem is, yeah. So here, after we split, we can copy these 2 subarrays back to the original array. Yeah. Make the arrangement. Yeah. Yeah. To get the divide step. Yeah. All right. But here, there is one big problem in this simple method. Okay? Is the solution acceptable? Due to that problem, it's not good. Yeah. The reason is not to use space efficiently. Not to use space efficiently. Look at the extra space we need. The same size as the original array. That's too much. That's too much. We don't want to use that much extra space for this step. We can do better than that. Yeah. So our next step is we want to work on the original array directly. We can shift the elements, but we do not use 2 auxiliary arrays. Think about that. Eliminate 2 auxiliary arrays, and we want to do the same thing just in the original array. Can we do that? Yes. So we can, yeah. So the idea, control extra space used. Yeah. So here, let me describe how do we still do the split without using auxiliary arrays. Yeah. Okay. On our original array, last element, the pivot. So this time, when we do manipulation, I make the first part of the array, S region. The reason I use S, smaller than, smaller or equal, right? Yeah, S means smaller, okay, or equal, yeah. L region, larger, just larger, not equal, including equal, okay, yeah, larger, L region, okay, 2 regions, yeah. But there is third region, U region. U means unprocessed. Yeah, some elements have not been processed, so we put them in the U region, unprocessed region. Then we manage these 3 different regions. A subarray corresponding to S region. Yeah. So containing all the elements less than or equal to P. Yeah. So S region. B subarray corresponds to L region. So larger than P. Okay. All right. Initially, they are empty. At the beginning, we do not have any information, so they are empty. Yeah. But we grow. Every time we do one comparison, we can grow either S region or L region. Okay? Yeah. Growing. Yeah. The unprocessed region at the beginning contains all the elements except the pivot. Then every time when we select one element in the U region, after comparison, we grow S region or L region, then we reduce that U region. At the end, the U region is empty. Then we finish the processing. Okay, look at that procedure. Think about that. Whole procedure, processing, scan step. Okay, all right. In my next video, I will use a concrete example to show you this implementation idea in details. All right, so let me stop our third video here.